In this video, we're looking at ECAA 2020, Section 1, Question 25. So, we have a rectangle, WXYZ, which forms a perimeter around 4 identical fields, each of which have walls separating them. We know that the total wall length is 260 metres, and we need to find the length WZ that maximises the area P. So, how shall we approach this question? Well, let's find the area P first, just in terms of some variables. So I'm going to label these sides A and B, and that makes our area P as AB. But obviously we can't get much from that at the moment. We need something with a numerical value in to be able to solve for this. So what information do we have that will give us a number? Well, we know the total wall length is 260 metres, so we can work out the wall length in terms of A and B and make it equal to 260. So that's 260 equals 8A, so all these sections at the top and bottom here, plus 5B, so that's 1, 2, 3, 4, 5. So that's our total there. So now we can rearrange this to solve for A or B. So let's start with taking 8A away from each side, and then we can divide through by 5 to get us 52 minus 8 over 5A equals B. So now we have our value for B. Let's put it back into our P equation. So we're going to get the area P is equal to A times 52 minus 8 over 5A, or 52A minus 8 over 5A squared. So we have our area P. But what do we need to find? We need to find the area that maximises P. So how do we find something that's going to maximise it? Well, we need to differentiate it and then set that differential in there to be equal to 0. So take a second, see if you can work out our differentiated P. So the answer to that is going to be 52 minus 16 over 5a. So we're just taking our indices, timesing it by our coefficient, and then decreasing the power by 1. So that's our answer there. And we need to set it to 0. So we can work through this and solve it through. So we're going to get 52 equals 16 over 5a, or 260 equals 16a, which times it by 5 there, and then a equals 260 over 16. And then we can simplify that down, just dividing it by 4 on both times, 65 over 4. So we have a numerical value for A. This allows us to work out our lengths. So the thing we're looking for is WZ, and we know that equals our length B there. And we also know that B is equal to this expression, 52 minus 8 over 5A. And because we now have our value for A, we can plug this in. So just timesing those fractions together, top and bottom, and we get 52 minus 520 over 20. Now this can cancel down. We just get rid of those zeros. That's 52 divided by 2, which is 26. So 52 take away 26 is 26 metres. And that is our answer, which corresponds to answer B.